Welcome to the next lesson in Math 8. This is Unit 3, Lesson 4, Comparing Proportional Relationships. I'm going to try something just a little bit different today. I recognize that the technology takes a long time for me to go ahead and navigate through and teach you at the same time. So I'm going to use a hybrid of the two different things using my document camera as well as my online. So here we go. First thing that we're looking at is our warm-up. An equation of y equals 4 2/10 could represent a variety of different situations, and it certainly could. We're supposed to write a description of a situation represented by this equation and decide what qualities x and y represent in your situation. Then we're supposed to make a graph of that situation. So I have this situation right here. I'm going to be showing you these same questions right here. You can go ahead and fill all those in that you see on your McGraw-Hill, but for the rest of this video, I will be showing just these ones here. You see the exact same information. Write a description in a situation represented by this equation. Decide which quantities x and y represent your situation. I think I want to have, let's see here. I want to have something where I am just jumping from place to place. So what I'm going to write with this is say I can jump 4 2/10 feet in one jump. The question is how long can I sustain that? Well, I don't know, I'm old, but we can see how long it works. But what we have in this is we have a constant rate. And that constant rate is this, jumping 4.2 feet or 4 2/10 feet every single jump. And so what I need to recognize from this piece is what quantities are x and y representing. We're going to say let x be the number of jumps and let y be the total distance in feet. Now I need to make a table and a graph to represent that situation. So there's a handy little table and graph that I've already made for this situation. We need to transfer that information that we put right here. And we would put right here, we would say number of jumps and then distance, in this case in feet. And we want to go ahead and go with those pieces. So let's say if I take a jump of my very first jump, remember that my equation was y equals 4 2/10 x. So that means that after one jump, if I substitute 1 right here, 4 2/10 times 1 is 4 2/10. If I take two jumps, then I can go ahead and substitute that value and make this 4 2/10 times 2 is 8 4/10. As you can see, I can continue this pattern because I can substitute anything I want for x that is reasonable. In this case, I don't want to substitute anything that's negative because that's not really reasonable. But there are some certain numbers that will make this easier, especially when there's a decimal value. In this case, I know that this is the 10ths place, and so if I take a multiple of 10, I will get a number that's actually a whole number. So this gives me 42. I also can play with that with a little bit of understanding that this came out as a positive value, that if I wanted to add on one more, I betcha if I multiplied by 5, I would get 21. So that's enough information to go ahead and graph this. So next to it, I have a graph here. This is a blank graph, coordinate plane. We're going to put on these values, here's the y coordinate, here, or the y-axis and the x-axis. We want to put the number of jumps on the x-axis and then the distance in feet on the y-axis. And now we need to determine some appropriate intervals. My intervals for the jumps is pretty easy. I could sit there and call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because that's the highest I need to go for this table. But on the other side of this, I need to consider some other distances that are here. And I see a lot of decimals, but I see also 10 goes up to 42. So how would I go ahead and navigate through this? I think by ones really would not be reasonable. Twos would also not be reasonable, but fives wouldn't take me very long. 5, 10, 15, 20, 25, 30, 35, 40, and I'm going to go to 45 simply because 42 is between 40 and 45. And now all I have to do is actually graph. Simply, all I have to graph is 2 points. I know that if I don't jump, I don't have any distance. If I graph this final point right here, that will also tell me where my last point is on my axes. And so just under halfway, approximately right there. And then the coolest thing about this, as long as I did my work right, I know that 21 divided by 5 is 4 2/10, or a constant proportionality. 42 divided by 10 is 4 2/10, and so on and so forth, which means that all 4 of these ordered pairs, since they are all proportional and they all follow my rule of y equals 4 2/10 x, they must be on this line. So that makes this 1 and 4 2/10, 2, 8 and 4/10, 5, and look at that, just above 20, so that's 21. And we can see my information there. Make sure I answer all the questions for 4-1, and that's it. 4-1, what's the relationship? That one's all done. See you in the next video.